Hey guys, so this is the last question of your homework number 6, and the question here, we are looking for the probability of x bar between 58 and 63. Obviously, because we are using x bar, so this is going to be the central limit theorem, right? So every time you are using x bar, is central limit theorem. Okay, so let's get into the problem. So what we need the mean, all right, and the mean here, the average lifetime is given by 60 months, all right, and the standard deviation is going to be 8 months. So those are the two keywords. Now, central limit theorem usually comes with sampling. So the sampling is mentioned over here. The n is going to be 34. So let's take a note. The mean here is going to be 60. Sigma is going to be 8. And n is going to be 34. So 34 is greater than 30. So what we're going to do, we're going to use the z table, right? Okay, so then they lay down the question, right? So what's going to be the probability that the mean lifetime, so they didn't ask about lifetime only. If they ask for lifetime, that will be x. If they add the word mean to the lifetime, that would be x bar. All right, so this is our question. Now let me try to explain what's going on here. So what are the steps and how we're gonna proceed with this. If you read through the problem here, the original population, they did not mention it is a normal distribution. It just say large population. All right, so what's the meaning of this? It means that our original population is any distribution. All right, so have the mean, this is 60, and sigma is going to be 8. So what we're going to do, we're going to use the central limit theorem with n equals to 34. So once we do this, we're going to transform this any distribution into a normal distribution. The mean will be called mu x bar, and that's going to stay the same as 60. However, the sigma x bar, the standard deviation, the new standard deviation, it can be the old one, which is 8, divided by radical 34. And then, so let me put the axis as well. So this is towards the x-axis. The axis here is going to be x bar. And then we're going to make the standardize, and we're going to jump into another normal distribution. However, this is going to be a standard normal distribution, and in order to get there, we need to standardize it with the formula. Z is going to be equals to the x bar, the values from the previous one, minus the mean of the previous one, mu x bar, which is the same as mu 60, and then divide by the new standard deviation, which is sigma x bar, and that's the old sigma divided by radical n. All right, so this is the formula that we are using. All right, once you standardize it, you're gonna get z values here. The mean would be 0, sigma would be 1, and the standard normal distribution is always coming with a table, which is the z values here for this case, and the z values basically that's the probability. So the probability is right here located, so it's a long way. All right, okay, so the application of this is not so difficult. So what we're gonna do, we're gonna rewrite this equation, probability. We're gonna put 58, leave a space, x bar, leave a space, and 63, leave a space again. Then we're gonna apply this standardized formula directly. All right, as we are using the previous values, right? All right, so I mean the original values that over here. So it can be one jump at once, right? We're going to do all the steps in one step. So what we're going to do here, x bar, we're going to take away the mean and then divide by sigma and divide by radical n. All right, you can put the parentheses, numerator and denominator. So for the left side and the right side, instead of writing mu Greek letter, we're gonna substitute it with the value, which is 60 minus 60 minus 60, and then divide by sigma, which is 8, divide by radical 34. And we do this from the left side and the right side as well, right? Okay, so then now we can plug everything in the calculator. So this is going to be calculated with a calculator. This value here, it became the z value, and this is going to be calculated as well with the calculator. Okay, so let's go to the calculator and plug it in. We start with parentheses, 58 minus 60, close the parentheses, divide by, open the parentheses again, 8, divide by square root, which is second and squared, 34. So now you need to exit the radical sign, and that's with the arrow, and then close the parentheses and enter. So this is going to be minus 1.457, and if you round it to 2 decimal places, it can be minus 1.46. All right, and then we're gonna do the second part here. So we're gonna reuse the same formula, enter, and we're gonna go all the way in the beginning, and we're gonna change 58 into 63. So 63 here, and then enter again. So this is gonna be 2.186. So this is gonna be 2.19 if you round it to 2 decimal places, right? All right, so what's going to happen here? This value over here, whenever we get it on the table, that's going to be the highest probability. So we're going to put it first, and then we're going to subtract the value of the first one, which is going to be the lower probability. So let's go to 219. 219 here. 2.1. All right, 2.1 and 9, which should be the last one. So the 9 is right here, and this is going to be 9857, 9857.0. And right now we're going to look for minus 1.46, minus 1.4 is right here, and then we're going to go all the way to 6. This is the column of 6. The intersection is going to be 0.721, so 0.0721. All right, the calculation should be give us the answer. So the difference here, let's type it in on the calculator, 0.9857 minus 0.0721. Enter. So you're going to be 9136, 0.9136. Let's plug it in. Great, that's correct.